You might have heard of layer 2s or even layer 3s, but how do they work though? Even though we have done many layer 2 review videos, I would like to take a step back to the basics and create more educational content for the Gem Crypto fan this time. This is actually part of the fundamental analysis for a crypto project, so next time you see some new layer 2 or layer 3 projects, you can better assess whether they are good projects fundamentally or not. As we know, new projects usually generate more hype than older ones, but at the same time, there's so much rubbish out there. We really need to know if they are bullshitting, and we need to be able to filter out those rubbish. So this video will explain all the concepts of layer 2 and layer 3 and turn you into a crypto expert. I'll explain each of the concepts with examples and projects that represent the field in an easy to understand way. So if all this sounds good to you, make sure you subscribe, sit back and have fun. So to understand all these fancy layer 2 and layer 3 stuff, let's go back to how Ethereum is built, just so we are on the same page. Ethereum's architecture is built on 3 layers: the data availability layer, the consensus layer, and the execution layer. Each layer plays an essential role within the Ethereum ecosystem while working together to provide an efficient blockchain power system. So now let's dive into each of the layers and learn about what they do. The data availability layer in Ethereum makes sure all transactions are available and accessible to everyone. This allows users to independently verify transactions, keeping the network transparent and trustworthy. This layer records all transactions and smart contract interactions. Smart contracts let developers create dApps or decentralized applications, which are peer-to-peer software with specific use. These dApps power various Ethereum functions like protocols, DeFi and NFTs, etc. So think of the data availability as a huge library that keeps all the information easy to access. This is crucial for anyone who wants to check the current state of the Ethereum blockchain and ensures the network remains trustworthy and decentralized. Consensus layer. The consensus layer is where the Ethereum network agrees on the current state of the blockchain. It's really like the backbone of the blockchain, making sure everyone agrees on which transactions should be added next. Ethereum uses something called proof of stake for this. With proof of stake, participants can stake the ETH to become validators. These validators process transactions and add new blocks to the blockchain, helping keep the network secure and running smoothly. In September 2022, Ethereum switched from proof of work, or aka mining, to proof of stake, making the blockchain more scalable and energy efficient. There are also future upgrades planned like sharding, which will make Ethereum even faster and more scalable. Execution layer. The execution layer in Ethereum network is where smart contracts and transactions are actually carried out. It takes the instruction from transactions and smart contract interactions, processes them, and updates the blockchain accordingly. At the heart of this execution layer is the Ethereum virtual machine, or EVM. The EVM interprets and processes the code from smart contracts, allowing developers to create dApps on the Ethereum network. Now, imagine if you take out the execution layer to be a separate layer on top of settlement and data availability. Guess what? That's what all the layer 2 roll-up solutions do. Layer 2 basically means to handle all the transaction authentication from layer 1. In other words, with the roll-up solutions, layer 1 can now only handle the creation and addition of blocks to the blockchain, and the layer 2 network sits over the layer 1 network and continuously communicates with it. And there are mainly 2 types of roll-ups, which are optimistic roll-ups and zero-knowledge roll-ups, aka SECI roll-ups. Optimistic roll-ups assumes transactions are valid by default and only runs computation via a fraud proof in the event of a challenge. Some of the prominent projects in this field are Arbitrum and Optimism. I'm sure most of us have heard of them before, and if you want to learn more in depth about Optimism, click this video on the top right corner. However, I haven't got an Arbitrum video on Jam Crypto yet, but if you want to see one, let me know in the comment section below. And as for SegK rollups, it runs computation off-chain and submits a validity proof to the chain. So kind of a pessimistic rollup if you think about it. Anyways, bigger projects of SegK proof include SegK Sync, Starknet, and SegK EVMs. Both optimistic and SegK rollup solutions mitigate network congestion and enhances throughput speed while splitting transaction costs across a batch of transactions, allowing as much as 10x to 100x reduction of Ethereum gas fees. Furthermore, the combined advantages of higher transactions per second and lower fees increase L2 projects' resource capacity for the improvement of user experience and expanded the scope of dApp deployment. Well, if you're still watching at this point, give yourself a round of applause. This is some very technical stuff most people haven't even heard of, so I'm really proud of you for sticking around. So far, we have covered the Ethereum blockchain architecture and layer 2s, but we're still missing something more tailored to specific project needs, and that's where layer 3 comes in. Layer 2s have tackled scalability, but there are still some issues like privacy concerns because everything on the blockchain is so transparent and you can't do specific requests for app performance. Layer 3s address these shortcomings. They build on existing layer 2 solutions, combining cross-chain technology with layer 1 and layer 2 for a new chain expansion solution. By having their own smart contracts and dApps, they can focus on handling decision-making and execution of follow-up actions. Now, some would argue, are layer 3s actually necessary though? Well, let's see what the Ethereum co-founder Vitalik Buterin has to say. He mentioned the idea of layer 3 isn't just about stacking the same scheme on top of itself for exponential scaling. Instead, newer layer 3 ideas are more sophisticated, assigning different purposes to the second and third layers. So what Vitalik means is that while layer 2 focuses on scaling, layer 3 offers customized functionality like dedicated and customizable infrastructure, privacy, and specialized applications tailored for specific needs. This means layer 3s help with the adoption of dApps and provide a faster deployment cycle. For instance, a layer 3 solution could offer privacy-preserving transactions without including them in public layer 2 solutions. Some examples of layer 3 projects are Starkware, Ops Network, and SegK Link. If you guys are interested in knowing more about these projects individually, let us know in the comment section below as well. But to summarize in broader terms, these layer 3 projects are basically designed to provide dApps with a more scalable and efficient environment, each with its own governance and economic systems. So if you ask me, layer 3 isn't just about making things even faster or cheaper than layer 2s, because come on, it's pretty cheap to use layer 2s already, but about catering to each dApp's needs or providing privacy, and that's where I see the value in all these layer 3 projects. Alright, so we have covered a lot today. We have broken down the basics of the Ethereum blockchain architecture, layer 2s, and even venture into the more specialized layer 3s. From understanding how the data availability and consensus layers work, to seeing how rollups enhance the execution layer, we've touched on everything you need to become more knowledgeable in the crypto space. I hope you have a better understanding of these layers and the performance in the Ethereum ecosystem after this video. We definitely don't do a lot of technical stuff on this channel, so if you want to see more similar content like this in the future, be sure to let me know in the comment section below. In the meanwhile, if you also want more regular updates from me, make sure to follow me on Twitter and Instagram, and I'll see you guys in the next one.